in the economics track. Thanks for joining us. Really looking forward to the upcoming speakers we have. And we're going to kick off this morning with Carolina and Mallory. And forgive me, introduce your presentation this morning for us, and I'll let you take it away. Thank you.
Okay, thank you. I'll start sharing here. Okay. Okay. Are you all okay? Thank you for having us in your event. My name is Carolina Manrique. I'm an associate professor at University of Idaho. And kind of also presenting with me is Mallory Buscemi. She's a graduate research assistant currently in her third year of Master of Architecture program here at University of Idaho. And we are two of the women in the architecture group referred as Cradle to Cradle Design team. We're part of 4 teams that are part of a collaboration in a National Science Foundation grant regarding developing a bio-based circular framework for 3D printing housing with wood waste. So this presentation is about some of the kind of things going on, some of the insights, some of the things we're working on from our first year of this grant. This is a 4-year grant. And one of the kind of big motivations of this grant was that brought together kind of a various expertise was regarding a concern with waste in the construction, architecture, engineering, and construction industry. And also just about, I mean, it as a problem and as an opportunity, right? So in architecture, we're always thinking about, I mean, what can we do in terms of enhancing and giving value to the resources that are out there. And waste is becoming, of course, a big problem that accumulates in the U.S. is a big problem. And we're in the Pacific Northwest, and we have an important wood industry. A lot of the construction and architecture products are related to the wood industry with wood framing and current developments in the mass timber production. And that's also, you know, part of things in the cycle of the construction that become waste at some point. So we're looking at that issue. And we're also kind of understanding, you know, that it is a problem. It's part of not only in the construction industry, but also the timber overall industry has different layers of producing waste. So we're trying to see this waste as an opportunity as a material now, instead of something that needs to remain as in the category of being a waste. And in terms of, this is a problem that's not unique for the U.S., of course. There's all this kind of global concern about a series of, of impacts we're generating with the development and growth of our industries at different scales. So affordable housing is the other kind of big motivation that's triggering this grant and putting us together with different type of disciplines concerned about the topic in different ways. And it's the issue regarding demand, the increasing demand, increased amount of population, but also the lack of affordability of what's being offered out there. And we're kind of lagging in that, being able to provide this needs for population. And we're seeing this, of course, a big issue, both global and U.S. scale. We're looking at just continuously, we're bombarded, obviously, with through news, because we can directly, all of us connect to this need, right? The housing need and this issue, you know, regarding how we have the opportunity from the construction, architecture, and engineering industry to maybe see ways in which we can reduce, the cost in various ways. We are that's those two kind of big triggering topics were the ones that put us together put together different type of disciplines that were also kind of seeing opportunities with 3D printing or additive manufacturing developments. And there's also part of our team are experts regarding composite kind of innovations in composite, specifically related to wood. So we are first of all, we're kind of a multidisciplinary team. So we have architects, we have structural engineers, we have mechanical engineers, we have people specialized in wood composites, we have people specialized in testing, durability in materials. We have researchers involved in chemistry and being able to kind of deal with very complex developments of new materials. And from our point of view, the women kind of presenting here, we are very focused on how to tie in all these different disciplines towards the notion of circularity, this idea of connecting waste and bringing it back to that cycle of the construction and industry. And we are highly concerned about the impacts that our industry produces and the opportunities of increasing value in sustainability and resilience topics. So kind of the big kind of target here is developing this something that we're calling print timber. That's a name we kind of got together and agreed on when we started this grant as a proposal, and then moving onward when we got the award by the NSF. And it's this notion of developing this biologically based composite material. That's what we call print timber specifically, but it's more than that. Our grant is about developing the full framework, right? The circular framework of understanding how this product then can become something that's applicable, in the construction industry. And the issue of being bio-based brings a series of problems, right? There's a lot of development of additive manufacturing in the construction industry, a lot focused on materials such as 3D printing with concrete. So we're highly concerned about that kind of high use of concrete in our industry, and we want to kind of aim for more bio-based materials, and that comes with some challenges regarding current additive manufacturing technologies. And there's also, of course, the concern about the binders that would allow to put together this material, which are a lot of what the bio-based resin group works on. So we're 4 teams, as I mentioned. The bio-based resin is all about the development of the resin specifically that's going to bind what we call the wood flour. That's what we're kind of recovering, from waste, sawdust produced by kind of local industries. So they're kind of going through the whole challenge on developing the whole process of kind of chemistry, and the science to be able to develop this bio-based resins. The additive manufacturing group is led by the PI, the principal investigator of our grant, who's Michael Maughan. He's a mechanical engineer. He has specialized in additive manufacturing. Prior, a lot focused on metals, and through previous grants and this current grant, now working on how to develop that technology for 3D printing with bio-based materials. The performance, and we have a third team, which is a set of engineers and College of Natural Resources faculty and researchers who are kind of putting together this notion of testing, everything we are developing with the resin team and the 3D printing team, and actually testing the properties of this new material we're aiming for. In our cradle design team, the architects involved here, and we have also a mechanical engineering specifically kind of focused on energy performance in buildings. So we're all about application, right? So we want to know, what can this thing do? What can this thing be applied for in the construction industry? What can this new material be in our housing, and how would affordability be affected? We have 3 goals. We are developing scenarios through design, so research by design. So kind of playing a little bit with speculating, what can this material do? And we're also working on really identifying sustainability and resilience parameters to kind of be able to determine, how successful this material can be in the full cycle. And a huge goal for us, and that's one of the big reasons we wanted to participate in this conference, is this notion of connecting with others, and reaching out to communities and users and people involved in this industry to kind of promote this notion of what's going on in the construction industry and resilience and sustainability goals. Our team is all about this notion of crowd-to-crowd design, which is kind of really giving value, to what was considered the end of the cycle and bringing it back to the circularity. And this is a little bit of that notion. So this kind of, we're really focusing on trying to focus on of materials that will biodegrade and go back to, to the whole full cycle, or they can just be part of the kind of natural systems back again. We're highly concerned about moments where this happens, which is this notion of the difficulty of separating, materials that are mixed and not being kind of easily recycled and brought back to the circularity notion. And again, about nothing of this is going to be successful if we don't educate, our students at University of Idaho, if we don't involve other disciplines with this mindset, and also if we don't reach out, to other people interested in this community for this approach. We are one of the key things we've done is kind of just trying to get a sense of those parameters and how they compare with other systems that are traditionally used for housing. So that's a comparison that's necessary, that we need to see how would our product and compete. I'll let the kind of next section of the presentation go to Mallory.
Okay, sorry about that. I think we got that outside noise away now. So hello, good morning, everyone. So just continuing the conversation, while we have many projects, obviously, that are still in the experimental stages, AM has already made great strides in the construction industry. So they've revealed similar advantages of 3D printing as a construction method when we are comparing that to traditional construction. And we've kind of broken it down after looking at the case studies, just some common advantages of 3D printing as stated by the companies themselves that are in this field. So AM saves time, and specifically in the building process and equipment setup and tear down. It's developed safer workplaces because the machinery is handling the build while people are just kind of operating nearby and overseeing the projects. Less employees are required on site to operate the machinery, so no need to hire larger construction crews. The use of local or renewable materials eliminates supply chain delays. Local materials reduce the building's carbon footprint. And AM supporting a circular economy by reusing or recycling the product after its life cycle rather than sending it to a landfill. It can optimize material geometry, which creates a more flexible product that may not require connectors or additional materials, offering cost savings to builders, contractors, and/or homeowners due to material savings and reducing staff requirements. 3D printing also ensures a more accurate build with less human error and has integration potential for electrical, wiring, and plumbing systems. So there's various industries within AM, which I'm sure everyone here is aware of: military, medical field, aviation, maritime, and even space. There's various methods ranging from multi-axis systems, gantry arms, and there's various materials, which is what we're kind of looking at too and exploring with wood and seeing as far as what's out there with the case studies, including steel, sand, plastic foam, and nature-centric designs. So to see each impact at work, we're going to be analyzing a few different case studies that we categorize by on-site versus off-site construction types. As it suggests, on-site construction involves printers being brought to the site and printed directly on top of foundation, whereas off-site is going to be prefabricated buildings that are printed as modules, transported, and then assembled on site. So here we're going to review 4 different examples of on-site assembly construction process and descriptions of how each case study is making waves in the AM industry, starting with Icon, which is likely the most well-known company based out of Austin, Texas, that developed the first single-family 3D printed home in the market in the US. They developed their own proprietary concrete material, which is applied on the interior and exterior, which eliminate the need for additional materials. And they're using a large gantry style print system to allow for efficiently printing multiple homes at once while only requiring 2 to 3 people to operate the machinery. Next is Mensa Corte. It's a 2-story structure printed from concrete in Germany. They integrated pipes and electrical systems during printing, which expedited the process. And a newer one with Hannah, it's with Perry and Sive. They partnered with Hannah on this project to create this 2-story home using a hybrid of wood frame construction and 3D printed concrete. As the technology progresses, they're going to apply this technology to more multifamily, multi-story homes. And we also have Wasp, which is a project in Italy that uses local soil to print 2 dome-shaped structures simultaneously, which saves construction time. No materials were required to be transported, which made this project carbon neutral and adaptable to its environment. And we have the walls, roof, and cladding, which were all printed with no need for additional parts or connectors. So as we start to explore off-site assembly projects, you'll begin to notice that they're generally smaller scale because of the limitation in module transportation. Starting with DUS Architects. This project is in the Netherlands. It was experimental build using printed bioplastic that was injected with concrete. Each module was printed as click connections rather than requiring addition of more common connection systems. And even more unique than using recycled plastic, the entire cabin can be shredded and reprinted. Then we have Azure Printed Homes based out of California using recycled plastic. And they claim that they're printing 70% faster or in 12 hours compared to competitors with 30% less cost than traditional construction methods. The structure itself is self-supporting, which eliminates the need for additional materials and supports. And they print the structural skeleton, exterior sheathing, water control barrier, exterior finish, and they leave passageways for the utilities. Next, we have Wone Homes, which is out of Denmark, and they are scheduled to complete their first print in 2023. So the final picture here is just a rendering, but they're focusing on smaller scale, again, student housing, vacation homes, printed from wood waste and a recycled plastic binder. Unlike the other offsite approaches of a fragmented structure, these modules are created as one continuous piece, making up the floors, wall, and roof. The sizes are customizable in order to fit a variety of square footages, and it's going to be offered as rental units coming in 30% below the present market prices in Copenhagen. And then out of Oakland, California, we have Mighty Buildings. They optimize their proprietary stone-like material using 60% recycled resins. And then they actually harden the material using a UV light, which is very unique to this specific project. They also are claiming that this process is creating a product that's lighter than concrete while offering 5 times the tensile and flexural strength. Next, we have University of Maine, which was just recently completed at the end of last year. They're printing floors, walls, and roof using wood fiber and bioresin. We're still kind of learning and exploring more about this case study to follow up on the use of wood and bioresins. They also claim that this is fully recyclable. And they also used wood as the insulation material of choice, which allows for customized insulation. And finally, we have components, which is a separate type of 3D printed offsite construction worth mentioning, focusing on structural or weight-bearing elements that can easily be applied to existing construction methods. So there's a few examples here. First is University of Southern Denmark. They have designed various strategies that use 3D printing that optimize material performance. So there's a 3D light beam, which is a porous concrete beam that was printed in all directions to reduce the weight of the beam while still maintaining its strength. And on a smaller scale, they have struts and nodes, which can be customized to the project itself. The This eliminates the need for mass production and can adapt to unique designs which otherwise wouldn't be supported with conventional connectors. It's also a great approach to circularity, as it encourages us to think of 3D printing and construction as a way to reuse and recycle materials. And finally, we see a different type of structural project by Holcim. It's a striatus bridge, which is a modular offsite constructed project. It works in compression without the use of reinforcement or binders. These are the types of projects that are not receiving as much attention as 3D printed homes, but they may be just as impactful, if not more impactful, due to their flexibility of application. So now we want to go over one of Print Timber's Education Center tasks, which involved a semester-long studio where students were asked to investigate new construction techniques and bio-based materials to design a microhome. New iterations were completed weekly and involved projects that we see here. So some examples include a Mend House, which uses 3D printing technology to repair homes that suffered damage from natural disasters. So these are just a bunch of examples of what students kind of created and put together last year. Next, here's a second poster just showing more student examples, including regenerative materials such as algae or mycelium to capture CO2 emissions and generate energy. So some key takeaways from this presentation: interdisciplinary and interinstitutional collaborative work in additive manufacturing contribute to strengthening research capacity, foster workforce development and diversity, and to generate economic and sustainability impacts in architecture, engineering, and construction. A cradle-to-cradle design approach is required for developing design speculations and scenarios for AM 3D printing architecture applications and identifying and assessing sustainability and resilience parameters, and educating academics and professionals, users, and community members about opportunities with sustainable and resilience applications of additive manufacturing is critical to the success of any technological development and its application in this industry. So we appreciate your time. Thank you so much, and definitely reach out to either of us if you have any questions or if you just would like to connect with one of our teams.
Thank you so much. That was so much information. I had really no idea all of the efforts and research that's going on in concrete printing or in sustainable printing. I mean, I think we do hear a lot about concrete, but I think it's really interesting to see the broader scope and everything that's going on. If you have questions for Mallory or Carolina, please put them in the Q&A and we'll get to them. We do have a question for the audience for you. Are you looking at plywood waste as well? More adhesive than wood, but a lot of waste. If you take yourself off mute, I think.
Hi. Well, currently because it's still in the stages of developing the actual technology for 3D printing and bio-based, what we're using is kind of sawdust from one of the local kind of timber lumber industries, and that's right now our kind of element to produce the so-called wood pulp, right? So that's what we're starting to look at, and we're definitely kind of have in the list of the testing that the actual team that is working with developing the 3D printer itself, the PI Mike Morgan, has a list, you know, of kind of products that are producing all this waste that they'll need to start kind of testing out and combining with the different kind of resins production. But right now, this first year has been all about kind of testing, you know, what it needs, what the actual kind of 3D printed needs, you know, and the issues, you know, dealing with this type of material, and the actual kind of testing, you know, how these layers stick together, for example, which is a big kind of issue that needs to be solved in the process. So we're kind of definitely kind of in a pipeline of kind of waste produced by different products in the construction industry. But right now, it's all about kind of that kind of local industry providing that sawdust.
And how long is your grant? You're in the first year, you said, of your research.
Yeah,
How long?
we just finished the first year, and it's 4-year grant.
Oh, excellent, excellent. Next question from the audience is, how does your material process compare to the recently announced BioHome 3D project from Maine?
Well, that's something we're looking into. The concern that we have is that we're really kind of aiming for a complete bio-based material, and that's the big challenge. So the resin, so one of the advantages of materials that are more hybrid, is that they're able to then, I mean, it's already more controlled in terms of the 3D printing being able to do what they're able to do right now, which is pretty spectacular. A purely bio-based material, it's a lot more challenging, right? Doesn't have, I mean, we're still kind of comparing, for example, with current materials, right? Just comparing with concrete, for example, I've been comparing against like compressive strength capacity. It's already kind of a comparison that do. And then materials that are more hybrid in their approach, that are not necessarily purely bio-based, have kind of course, more spectacular properties right now. So this is one of the challenges, like testing, what are the limitations, or what needs to happen to provide this purely bio-based material with those like properties that would compete with other hybrids. And so things that are in the pipeline of testing is, for example, adding fibers, to maybe increase properties, that the current kind of wood flour and resin on their own might be lacking, right? So that's in the pipeline of testing in the future as well.
Excellent. Which 3D printing system manufacturer can provide today ready to 3D print wood equipment for commercial use? Or which one is very close? Is there one?
Well, for us, the one that I mean, it's probably a question for our PI, who would be on top of the whole 3D printer actually production or market. But one of the conversations we were having precisely with him was about, from the architecture point of view, we were kind of mind blown by the Maine example, right? We were like, "Wow, this is fantastic! You look what they're doing," And but then in the conversation was, well, we need to look into how much of that is really like a wood based like a really bio-based complete material, or are we talking about a hybrid? So we're still looking into that. There's one of the things that's been very interesting in the whole process is that as this is evolving so quick, we're getting to know these case studies in more depth, right? So initially we only get the information provided by kind of some websites or just kind of marketing, of the product themselves or the 3D printer itself. But then it takes a little bit of more time to be able to really get to know the details of the case study, right? Really, like when it's said that it's fully recyclable, what does that mean? What are the details of that? What are the details? What's the composition of that material? Like there's a lot of information that's still not completely out there, right? For us to know the details and get a sense that we're, what are we competing against? So that's part of our state of art is getting to understand these case studies, getting to understand when we talk about a material being resilient, that's one of the aspects where 3D printing with concrete is promoting themselves a lot. Well, we want to get a sense of what that means, and from an architecture point of view, we're thinking about resilience in a broader spectrum, right? Not just responding to disasters and being almost like a response that a bunker would do, in terms of withstanding anything that comes across. But for us, resilience ties into other aspects. For example, what about flexibility and the fact that how can we renovate these houses that are built as permanent structures for withstanding all this? What if there's a change that you want to do? How flexible is the house in the type of construction? How does that compete with framing, right? In our Pacific Northwest, which is such a successful, a approach, and which has, it might not be a bunker necessarily, but it allows for a lot of flexibility and changes in, in a household when a family grows, or or any adaptation needs to happen. So we are in that stage, that first year stage, in which we're really looking into how things are presented, and want to know more details about them, to see really how much, of those parameters that we're interested in from a sustainability resilience point of view, what are they, So to your question, our first example was Maine, right? Like, wow, I mean, it looks like they're kind of really producing something close to what we want, but we need to know more, about that case study.
So many different aspects in construction that you have to address, and so I can imagine there's just a lot of moving parts for you to look at and focus on your research, but then what's out there as well. You find it to be a collaborative environment?
Yes. So, well, there's a couple of things, right? The advantage of being in this kind of multidisciplinary group allows us to, as soon as architects, we get all excited about a case study, right, in terms of what's doing. And as soon as we're able to talk with the mechanical engineer who's specialized in the 3D printing, technology, or we talk with the, faculty from the College of Natural Resources who's kind of fully aware of the innovations in composite technology, in wood composites, then our immediate feedback is in terms of giving us a lot of tools to understand the case study more than what our architecture background would kind of see. Then immediately, what has been very interesting is, for example, Mallory has done a great job in terms of reaching out at the beginning of our grant. We were very excited with with what Icon was doing, and we are still excited about a lot of the things they're doing. So this idea of reaching out to them, and they were very kind of nice and helpful, telling us their story, and we need to kind of start reaching out to this kind of more newer case studies to find out more, and people are excited. I mean, the nice thing about the people involved in all this project is that everybody's excited, in terms of contributing somehow, like with, even if something is not fully recyclable, there's an effort, to get there. Even the concrete industry is making efforts, and making improvements, in their own process to make concrete more sustainable. It reduced the embodied carbon produced. So everybody's kind of on a similar boat in terms of this very kind of exciting, nerdy, pursuit.
An important pursuit.
Yeah.
Next question is, being in Africa, there's very little eco-friendly 3D printing construction happening, except of 14 trees. They're concrete based. Have you looked at what type of bio waste would be more relevant for Africa?
No, can you repeat what you said? 14.
It sounds like
trees?
14 trees. I'm not familiar with them, but it sounds like they're concrete based.
Okay. Well, no, and we haven't. We are tracking. So one of the things it's the flow of information, right? So as soon as we kind of use keywords to start in our searches, for any of this, there's certain predominance of certain kind of companies, that take over, the media and display. So we need to refine our keyword searches to precisely reach out to these other initiatives that might be a lot closer to what we're looking into, more maybe there's some kind of vernacular approaches incorporating this kind of advanced technologies in ways that will be helpful for us to to start thinking about how to address this goal of becoming fully bio-based, right, in other territories. We haven't. This is one of the purposes for us to join any of these conferences is, for example, hearing this question, right? It puts in a radar immediately something that maybe we were missing to have in our radar, but because we were focused on the big companies, right? Or or those things that by marketing, have the stage, more
Yeah, have the
visible.
visibility.
So this is the reason we are joining every opportunity we have to reach out and connect in this conference. This is part of it. It's not us telling a story, but we are learning, so this is the kind of questions that are very helpful, for us to then put in our radar for sure.
Yeah, it would be great if you connect on the networking floor. Maybe Petra, who asked this question, you guys could connect, and anybody else who has insight into this, and you guys can talk about it in more detail. But it brings up a good point that I was thinking about, is that not only do you have all these, sustainability and circular aspects to contend with, but then are you going to be looking at, what regions and climates, and what are their specific needs?
This is huge. I mean, this is
Mhm.
huge. Right? I mean, because right now the focus is on disasters, right? So this whole notion of so that's also local, like region based, right?
Sure.
Locally based issue, right? The Pacific or Northwest, we don't have hurricanes, tornadoes, right? We have other issues. We have fires, right? So fire is a big concern, for us. So climate's absolutely huge issue, in terms of a lot of those wall assemblies that we're looking into the different case studies. Well, the big ones we're talking about, the difference between Texas, Maine versus the Pacific Northwest, a completely different environment, different challenges in terms of that wall assembly and how that wall design, with it's not just a 3D printed element, but it's the full assembly, right? It's the whole, how is the wall dealing with insulation? How is the wall dealing with, kind of response to fire, fire performance? How do they weather? What's the durability regarding? So this is a big deal with our performance team, group number 3, the one that has all those experts in. We have a structural engineer, people really kind of focused on testing, the materials, and running, the different kind of codes that regulate, that materials are approved, for dealing with all these issues. This is huge. Yeah, climates for sure is a big parameter for us.
That's interesting that you have a team of experts just dedicated to that aspect. The next question is specifically interested in mycelium, and if there has been some research in some of the universities or private companies in Africa. And if you don't know Africa specifically, maybe another region.
No, we don't know specifically to Africa. One of the things with mycelium is we were excited just to see how the kind of creative, exploration of this material. We have a lot of students of ours that immediately, when we show this one case study we had in one of our initial kind of stages of looking into what's going on with 3D printing, one of the ones that showed up was precisely the mycelium topic. One of the things we sense is that this is definitely a topic we need to look into. We haven't probably looked into it that much because we're focused on this whole kind of understanding housing and the materials used in housing so far. That has narrowed a little bit our approach in terms of the case studies we focus on. But one of the things that it's nice that you bring it up, it's because if there's a material that triggered immediate interest in our students, was mentioning mycelium immediately. I mean, more than any other material, immediately people were like, they wanted to know all about it, probably. So this is also for us a learning thing as faculty, to get a sense of the new generations, their priorities, the things they're looking into. Why is this material, triggering immediately that interest? We are right now so focused on this notion of the case studies dealing with housing. So we're understanding, the case studies we just mentioned, but but it's clearly an interest, on the new generations of other, type of, materials and approaches that are definitely not the traditional materials at all.
Why do you think the students are so interested in mycelium? I know you're still kind of looking into it, but what do you think it is?
I think they're just curious.
Mm.
They're curious about. First of all, the people that have. I think the case study we looked into it. What was the cups? Was that no? Which one was the mycelium one? Was it with the? It was not the cups that were kind of stacked. No.
Yeah, where it's basically a host, mycelium as a host, and so it's regenerative and grows. I'm never sure what the name was.
So it's funny because my mother is one of our students, right? So it's almost like we have also in our team, we kind of have a sense, of the things that triggered their interest, right? So this notion of just materials being kind of like so natural, right? The opportunity of regeneration, this kind of idea of working with nature, right? There's a huge tendency and interest in our students in kind of biomimicry. It's growing more and more, this idea of designing like nature does things, right? And how efficient they are and how just kind of natural and kind of well kind of connected rather than so artificial, and also they're interested even in terms of form finding that have to do with the more organic, forms, more versus the kind of standardized, orthogonal, rigid, type of architecture that a lot of our cities are built with. They're thinking about a different world already. I mean, they have in their they grew up in their head. They grew up with already this concern of sustainability, in nature built in, in there as a concern.
That's exciting to hear, actually, because it makes me hopeful, right? Because I love that they're thinking outside the box and they're thinking of their future. Mycelium is an interesting material because I think we see it used a lot in fashion too, and so maybe that's why it's very exciting. And it's beautiful. That could be one of the reasons. It may be too soon in your research for this next question, but what kind of 3D printing technology do you think works best with the timber print?
With the timber, what, sorry?
With your print material. It says timber print, but again, remind me of what it's called.
Print timber.
Print timber. Okay.
Just which is like 3D printing with bio-based, wood. So I think it's interesting because one of the out of the student speculations in that studio kind of two posters that we showed, that kind of is bleeding into the second year. Out of all those speculations that were in those two posters, there's one topic which is kind of the construction buddy. It's called construction buddy, and it's this notion of what if using the extrusion, with the 3D printer, the extrusion process. What if what are the opportunities of maybe producing like 2x4s that way? Instead of like light frame products like they used in light frame construction, right? What if instead of just directly kind of just cutting, the wood, the traditional way of obtaining, 2x4s, 2x6 to construct housing. What if this is produced out of this wood flour, based, and that's an idea that started to bleed into. It's not 3D printed in the sense that it's not layer by layer. It's more like using the extrusion process, suggested by it. So that was one exploration that's kind of bleeding into for us to look at. The other thing that we were thinking about is, it's funny that we are comparing, our print timber, our initial kind of baseline of parameters. That slide I was showing, comparing with CMU, comparing with light wood framing, or comparing with CLT. One of the conversations we were having is like, why are we not comparing with rammed earth, for example, in terms of, this kind of wood flour just kind of working, as kind of a more mass, type of kind of type of print, rather than trying to compete against concrete. Why are we not maybe sharing in comparison with other type of materials? So those are the things we're in the way of. So, and that's coming back of that multidisciplinary feedback, right? Because we don't know what this material is or what it can do until there's a test of properties, right? So
Right.
then the team does a little test, with a little sample and say, oh, right now we're getting a compressive strength of so-and-so, right? So, or it's not showing, and we have this idea of maybe adding fibers to kind of increase properties, in other type of kind of stress capacity, right? But then so it immediately puts the material in a very different category, right? If it's going to be a material that's going to be only used as a compressive material, then it has these opportunities. If then fibers are going to give other type of properties and they has kind of a better performance in tensile properties, then it puts it in a competing against other type of category, right? So in our architecture team, we're kind of, like we have this material that doesn't exist. Suddenly we have some notions of properties it might have, and immediately triggers in our head comparisons to things we know, like, okay, how would that compare against, ram's earth or other materials and things of that sort. So that's our kind of messy process right now.
Well, thank you so much for being here and sharing your research. Looking forward to what you come up with over the next 3 years.
Yeah.
Lovely to have you. Thank you.
Thank you. Thank you all.